Hello, my name is Edward and today I'm going to introduce you to the topic multi-track tape machine recorders. We're going to discuss about basic operation and maintenance. Let's go. Nowadays, tape recording is a niche in the audio industry due to the high costs for maintaining the machines and for the tape, as well as the limitations that the tape brings to the table. Let's say it involves proper care and attention, and it's much slower process than with digital recording means. Over the years, the main tape machine manufacturers were Studer, Tascam, Otari, and Ampex. Developed during the World War II, the J37 was one of the first tape machine recorders built by Studer. It offered over 30 minutes of recording and the option to edit, which was the first time audio could be manipulated. The machine was first used in 1966 for commercial purposes at Abbey Road Studios in London, where recording engineer Geoff Emerick utilized the machine while working with the Beatles on their most famous albums like Abbey Road and Sgt. Pepper's Lonely Hearts Club Band. Many other remarkable albums like The Dark Side of the Moon by Pink Floyd, Rumors by Fleetwood Mac, 4 by Led Zeppelin, and Space Oddity by David Bowie were recorded on multitrack tape machines in the 60s and the 70s. As years passed, the 24 on 2-inch tape recording became the standard and the most common format in professional recording studios. After I went in depth with the topic, it was the time to go hands-on, trial and error, to put in practice what I've acknowledged. Here we are at a beautiful private studio in Kreuzberg, Berlin, where I got a chance to record with the iconic Otari MX70, a 16-track tape machine recorder. Now let me introduce you to some key aspects about operating tape machines. When talking about tape, we can mention a few tape formats, and I'm specifically referring to the tape width. We have the 2-inch, which is one of the most common. You can record up to 24 tracks. The 1-inch, like the one I have right here, you can record up to 16 tracks. The 1/2-inch, which is most used for mastering, and the 1/4-inch, which can record as well up to 16 tracks. Most professional machines have 3 heads: the erase head, which is the first one, the recording head in the middle, and the reproduction head at the end. The erase head is responsible for erasing the stored information, while the record head is responsible for magnetizing the information on the tape. The playback head is responsible for monitoring, reproducing the signal stored on the tape. Other essential components are the capstan motor, located right here, which is responsible for correct playback speed, which helps avoid pitch and timing errors. Then we have the guides alongside the rollers, which are responsible for stretching and running the tape seamlessly on the transport. The tape is made from polyester, which ensures both strength and flexibility. It has a magnetic coating capable of storing information made out of metal oxide or metal alloy compound. This is why it sticks to a magnet. The working principle is quite simple. A wire carrying the signal is coiled around the recording head of the tape machine. When the tape passes in front of the recording head, the head magnetizes and polarizes, like an imprint, the signal on the tape. For more information about the electrical principle of the tape, you can follow the webpage of Hyperphysics, which is run by the Department of Physics and Astronomy by Georgia State University. To load the desired tape reel on the machine, place it on the left nab adapter. Take the tape through all of the guides and rollers in front of the heads and the capstan and coil it neatly onto the take-up reel placed on the right nab adapter. Spin the take-up reel a few times to make sure the transport is tight. Now the machine can be played to see if the tape is moving smoothly. If you are not sure how to roll the tape properly, please refer to the user's manual of your machine model. To unload the tape, it must be rewound until it reaches the end. The machine features a tape sensor responsible for detecting the tape. If the sensor cannot detect it, it will cause the transport to stop. Now it is safe to remove the tape reel from the machine. In order to benefit the most of the tape machine's properties, a proper gain stage level must be established. The DAW output signal level must be set to -18 dBFS or 0 VU if a mixing console is being used. A 1 kHz tone should be generated and played at these values. The input level must be adjusted until the meters on the machine reaches 0 VU. For pure analog saturation, the level of +3 VU is the sweet spot. +6 VU or more can bring distortion in the high frequencies. Depending on the desired result, this can be helpful or not. The playback level should also match the same level as the input. In order to record back the tape signal on the DAW, the interface input gain must be set to record the 0 VU of the machine as -18 dBFS in the DAW. The tape machines offer different options of monitoring, such as input monitoring, which refers to what enters the machines, and reproduction mode, which allows the user to listen back to the actual recording. The recording function will allow the input signals to be magnetized and stored on the tape. For this, depending on the model, a selection of buttons must be pressed. Punch-in recording is mostly used for overdubs. These are performed when it's necessary to insert new material into a track that has already been recorded without re-recording the entire track. Tape machines have the feature of selecting different speeds, resulting in various outcomes. The low speed offers a low fidelity yet warm-sounding recording, while the higher speed offers high fidelity and a clearer sound. Without proper maintenance, the quality of the recording or playback can be drastically influenced. Wow and flutter are undesired effects that can occur in case the capstan and the pinch rollers are worn out and dirty, the tape heads are not aligned properly, the reel tension is poor, the tape is stretched or damaged, or the motor speed is not consistent. For this, regular maintenance is advised. One of the easiest yet important maintenance steps is cleaning of the transport elements. Cleaning the tape path with cotton buds or swabs dipped in isopropyl alcohol prevents dust and tape residue from blocking any information from being magnetized on the tape. The magnetic tape does magnetize the heads and the transport elements, which affect the quality of the recording over time. The use of a demagnetizer is essential to restore the erase, record, and playback qualities of the machine. The demagnetizer must be held close to the magnetized elements of the machine, heads, rollers, guides, and moved slowly back and forth without touching them. The process must be repeated a few times for each component. For more information about analog tape machine maintenance, please refer to this article on Sound and Sound. There are only two manufacturers that still produce tape: RTM, which stands for Recording the Masters, and ATR Magnetics. Both tape are known for recording +6 levels, which means a very high headroom level. The most common tape formula is the SM911, like the one I'm having right here, which has great print-through properties and offers low noise floor recording. The SM911 has stronger magnetic properties, providing more output potential due to higher saturation flux and a thicker base, factors that contribute to the quality of the recording. Compared to Ampex 456, a popular discontinued tape formula, the SM911 has better storage and longevity properties. It is common for Ampex 456 to get sticky and harden the transport fluidity for both recording and playback. In this scenario, the tape must be baked at a specific temperature or thrown away in case the heat does not provide a remedy. For more technical details, refer to the spec sheet of the tape. Thank you for your attention. My name is Eduard, and this was all about tape machines for today.